Hi there, this is Dr. May, and in this video, we're going to look at literal equations. Now, literal equations are going to have more than one variable in them. We're going to be told which variable we will need to solve for. When we are told the variable we need to solve for, that's simply telling us which variable we need to get alone. All right? So, I like to take my highlighter and highlight that variable. So, in number 1, we're being told to solve for the y. I'm going to highlight it because that's the variable I want all by itself. So I want you to see that in this equation, drawing my imaginary line at the equal sign, this y, which we want by itself, is being added by negative 5x. So we want to get rid of this adding negative 5x. In fact, we want it to go to the other side so the y can be all by itself on the left side. So in order to do that, we're going to be the opposite of adding negative 5x. We're going to add positive 5x. You'll notice I wrote it underneath the negative 5x term, but I'm not going to write it underneath the negative 56 term. The reason I don't write it underneath the negative 56 term is these are not like terms. Now, like terms have the same variables, and you'll notice that the negative 56 and the 5x don't have the same variable. So, negative 5x plus 5x, those give you 0. And now we have the y. Remember, we wanted him all by himself, and we want the other side. Can't join them because they don't have the same variable, negative 56 plus 5x. Or if you wanted to write the 5x part first, you could say y equals 5x minus 56. And now that's my answer. You may be thinking, wow, my answer is an equation? Absolutely. But did we get the y all by itself? Yes. On one side of the equal sign? Yes, we did. I think we're going to need some more of those before we feel comfortable with them. So let's look at number 2. We're solving the equation for w. That means we want the w by itself. Now, there are two things happening to this w. This w is being multiplied by 2. You can see that right there. And this w is being added by 2l. So we're going to do the opposite of adding 2l, which is to subtract 2l. Again, I didn't write it under the p because those are not like terms. So on the left, I have negative 2l plus p equals 2l minus 2l cancel, leaving me with 2w. Now I need to do the opposite of multiplying by 2. The opposite of multiplying by 2 is divide by 2. But I want you to be careful about how I divide by 2 over here. Watch how I do it. I'm going to divide this by 2, and I'm going to divide this by 2. All right? So negative 2 divided by 2. Negative 2 divided by 2 is negative 1L plus P divided by 2. 2 divided by 2 is W. So I've got negative L plus P divided by 2 equals W. And I got the W by itself. Remember, that's what we were trying to do. These just take practice, okay? Because we're so used to solving equations to get like x equals 2 that when we're trying to just get another equation as our answer, I think sometimes it can be confusing. So if we look at number 3, we're trying to get the r by itself. I see parentheses here, so I'm going to have to take care of that first. I'm going to have to distribute. I'm going to distribute the p to the 1, and I'm also going to distribute the p to the rt. So let's see what I get. I get a equals p times 1 is p. P times rt is PRT. See how I just wrote them all together? Now, remember, we're trying to get the R by itself. So again, I'm going to highlight it. So what's happening to the R? It's being multiplied by a P and a T. It's being added by a p. So let's take care of the adding p part first. We're going to do the opposite of adding p. The opposite of adding p is to subtract p from both sides. So now I've got negative p plus a equals p minus p cancels, leaves me with PRT. Now I'm ready to get rid of the multiplying by p and t. So I'm going to do the opposite, which is to divide by p and t. Remember how we did it? We divide them individually. So dividing by p, multiplying by p cancel, t's cancel. I get r equals. This one's a little tricky. Dividing by p and divided by p is 1, but I can't lose the 1 that goes on the top. So I got negative 1 plus t, negative 1 over t plus a over pt. That doesn't look pretty at all, does it? But that's our whole idea, is we want to get the variable all by itself. All right, my friends, I hope this helps you as you're practicing with our literal equations, trying to get them one variable all by itself, everything else on the other side. Bye for now.